This is the review for Unit 7 continued, so this is the video for questions numbers 7 and 8. So for question number 7, it asks you to use the distance formula and the definition of the parabola to write the equation of each parabola in descriptive form. So just a little reminder that the distance from any random point to the focus should be equal to the distance from a random point to the directrix. And then this is our distance formula here. So for part A, they tell you that the focus is -5, 0, and the equation for the directrix is x is equal to 5. So the first thing you want to do is make sure that you rewrite what it is that you're working with. So you're trying to find the distance from a point to the focus and a point to the directrix. So the point that we're referring to can be any point on the parabola, so we just use xy. And then the focus is given to us as -5, 0. And then we're verifying that the distance from the same point on the parabola, so any random point, to the directrix, which the directrix is x is equal to 5. So that means when x is 5, your y value can be anything. So then from here, I'm just going to use my distance formula. So I'm going to find the distance between these 2 points using this. So I'm going to subtract my two x values. So I'm going to subtract these two. So when I do x minus -5, that's going to turn positive, squared, plus, and then now I'm going to subtract my two y values, so y minus 0, and then squared. And then that's all square rooted. And then I want to do the same thing again, but for the other set of points. So I'm going to equal that, so square root, subtract my two x values, so I'm going to x minus 5, squared, and then subtract my two y values. So then there's my setup, and then from here I just want to solve this equation. So to get rid of the square root, I'm going to square both sides. And then I have this, so x plus 5 squared. Y minus 0 is the same as y squared. And then this cancels, so I have x minus 5 squared. And then y minus y is just 0. So I could write plus 0, but I don't need to do that. And so from here, I want to get this part of it simplified. So I'm going to distribute both of these, and I know when I distribute, I'm going to get my x squareds will cancel, right? Because I'll have an x squared over here and an x squared term over here, so they will cancel. So I'm going to write this out twice and distribute. And write this out twice and distribute. And distribute the other side as well. And the whole point of distributing is so that we can simplify. And oops, part of that simplifying will be to cancel hopefully quite a few terms here. So distribute. So then I can subtract x squared from both sides. And then I'm going to go ahead and combine like terms here as well. So 5x plus 5x. And -5x and -5x. And then here I want to subtract 25, so these will end up canceling, so I would subtract it, but I'm just going to cross it off. And then here, so I'm seeing a lot of people try to add 10x over here, but then this would be equal to 0. And I'm trying to get my y squared by itself, so that means I want to actually subtract the 10x over. So I would get y squared equals -20x, and then I can divide both sides by -20. Right? And either one of those answers was okay. I didn't have to divide by -120 because that would have been in focal chord descriptive form. So either way, and there we go. Right, let's do part B. Okay, so for 7b, same idea. So we have the distance between the point and the focus. So the point on the parabola is xy, and to the focus. And then the distance between the point and the directrix, so the point P. And then any point on the directrix, so my y value is -3, and it could be at any value of x. So y is -3. And then from here I'm just going to put it into the formula. So I'm going to subtract my x values. So subtract a -4, that would turn into a positive. Subtract my y values. And then the square root of that. And then do the same on this side. So subtract your x values. And subtract your y values. And again, I'm going to have y minus a -3, so that would be y plus 3, and then squared. And I'm going to square both sides. So that will cancel. And so I have x plus 4 squared. And that cancels. So x minus x is just 0. I could write the 0, but I don't need to. And then I have y plus 3 squared. Okay, so now this is where we have to actually stop and think a little bit before we want to just start distributing. So I don't want to distribute all three of these. Not that that would be wrong. Like, I can distribute all three, but I don't need to, and there's the difference. So I don't want to distribute the x, but I do want to distribute both of these. And then how I'm making that choice is I'm looking to see, well, what would cancel? If I distribute this, I'll get a y squared. If I distribute this, I will also get a y squared. And so these two being multiplied out have something to cancel. Here, there's nothing of x terms on this side. So distributing this gets me nowhere, right? Because there's no x term over here to cancel. So I'm going to leave this one alone and just distribute my y terms. And that's because they will have like terms. X has no x with it, so I'm going to leave it factored. And then distribute my y terms out. And distribute the y terms on the right. Okay. I'm going to combine like terms. And my y squareds will cancel, right, if I subtract them from both sides. And then once I get to here, I want my squared term by itself, so I'm going to add 10y to both sides. And then I'm going to go ahead and also subtract 25 at the same time. Okay. And then I can factor 16 out of both of these. And then I can leave it in the vocal cord descriptive form, or I can do it into our just standard descriptive form. So I could divide both sides by 16. And then this would be just 1 over 16 here. And there you go. Okay, so that was question number 7. And then let's take a look at the last one here, which is question number 8, and we'll do A, B, and C. So for 8a, let me just write this down. So I want to get this always into either x equals or y equals form, right? So the two forms I have are x minus h equals 1 over 4c, y minus k squared, right? That's one of them. So the squared term is on the right-hand side. And the other, let me write that down as well. I'll write it next to it. So either one of these forms, right? So the important thing is that we have the linear part on the left, the squared term on the right. Linear on the left, squared term on the right. And then there should not be a coefficient of x or of y. It should be with your squared term. Okay, so that's always the part I want to make sure I'm paying attention to. So if I look at question 8a, I have my squared term on the left and I want it on the right, and I have a coefficient of x and I want it with the y squared. So I'm just going to flip these around, right? I'm not going to subtract anything over, I'm just going to flip it around. So I'm going to have 2x equals y squared, right? Because I want my squared term on the right, so I'm just flipping it. And then I want this always to be a leading coefficient of 1, so I want to divide by 2. So I have x equals 1/2 y squared. So this is where I want to do everything with this problem, right? So I'm going to find my vertex. And I want to find C, my focus, and my directrix. So my vertex is easy, right? That's just 0, 0. I'm not adding anything to x. I'm not adding anything to y. So my vertex will be 0, 0. When I find C, I take my denominator, and I always divide it by 4. So my denominator is 2. And then always divide by 4. So 2 divided by 4 is 1/2, or I can have it be a decimal, right? 0.5, either way. So now I don't want to find my focus and directrix right away without doing a sketch first, because that's going to help me decide the ordered pair for the focus and the equation for the directrix. So let's sketch what we have so far. So my vertex is 0, 0, and I know C is 1/2 or 0.5. So that means I either want to go up and down 1/2 or left and right 1/2. And how I decide is based upon the parabola. So this is an x equals, so it's going to be a horizontal, right? So horizontal, and it's positive, so it's going to be a horizontal that points to the right. So it'll be, some graph like that. So that means I want to go left and right 1/2 from my vertex, so here and here, so pretty tight squeeze in there. And then this will be my directrix because it's pointed in the positive direction. So that's crossing the x-axis at -1/2 or -0.5. So the x-axis, it's crossing at -1/2. And then my focus here is I went to the right 1/2, so to the right 1/2, and then up and down 0. So I'm just looking for where is that ordered pair. So now I need to find the focal chord endpoints in order to have a graph, and I know the total distance is 2, right? So the total distance is 2. So from my focus, I'm not going to go up 2 and down 2, I have to go only up 1 and down 1. Right? And then that gives me a total distance of 2. And there's my parabola. Okay. All right, let's take a look at 8b. Okay, so 8b is already in the correct format. My linear term on the left, quadratic term on the right, and I have no coefficient of x. It's moved over to the squared term. So I want to find my vertex, my value for C, my focus, and my directrix. So my vertex is at -2, what's changing the x value, and then what's changing the y value, so -2 and 3. So now for C, I take my denominator, which is 8, and then divide by 4. Always divide by 4. And that gives me a value for C equals 2. And I can write negative 2 as well, right, because this is a negative graph. And that reminds me that it's a negative parabola if I write C equals negative 2. I don't have to, but it's helpful, right? So let's go ahead and graph. So I'm going to graph my vertex first, which is negative 2, positive 3. This is an x equals graph, so that makes it be a sideways, right? Sideways, horizontal, and it's negative. So horizontal and negative means it's going to go this way, right? So from here I'm going to go, use my value for C. I'm going to go left 2, and that'll be my focus, right, because the graph is going to go like that. And then I'm also going to go right 2. So then my directrix, it crosses the x-axis on 0, right? So on 0, it's crossing the x-axis on 0. And my focus, I'm at 1, 2, 3, 4, negative 4, and 1, 2, 3, positive 3. So at negative 4, comma 3. And then I need my other 2 dots to create the graph. I am at a total distance of 8, right? So total distance of 8. So that means from my focus, I'm going to go up 4, down 4. Kind of fudging that last one there. And through the vertex and the vocal cord endpoints, and there's my parabola. Okay? All right, last question. So for 8C, I'll just do it in here. So again, I want it to have my squared term on the right, which it is, and I want my linear term on the left. So the minus 2 doesn't belong to the x, otherwise it would be in parentheses, so that means I want to add the 2 over. And I want to find my vertex, my value for C, my focus, and my directrix. Okay, so for my vertex, I'm adding nothing to the x value, so that would be 0. And I'm adding 2 to the y value, so that would be negative 2. For C, I take my denominator, which is 12, and always divide by 4. So 12 divided by 4 is 3. And do a little sketch before I figure out the other values, right? So this is a y equals graph, so it's going to run along the y-axis, so it'll be vertical, and it's going to point up because that's positive. So I know it'll be pointing up because it's a y equals vertical, positive, up. So my vertex is 0, negative 2, so over 0, down 2. I know my value for C is 3, so this is a vertical graph, so I'm going to go up 3 and down 3. There's my focus, and down 3. There's my directrix. So my focus is at over 0, up 1. And then my directrix is at 1, 2, 3, 4, 5. Is at negative 5. And it's crossing the y-axis, right? So it's going to cross the y-axis. So it'll be a y equals. And it's not a coincidence, right, when it's a y equals. Or on the other ones that we did were x equals. So my focal chord width is 12, so the total distance is 12. So that means I need to go left 6 and right 6. And I'm doing that along where the focus is, right? And then through my vertex and the 2 focal chord endpoints. And there's my graph.